Hello everyone, my name Muhammad Munim Agul. I am student at Altimbash University, Department of Information Technology. I am talking in this presentation about knapsack problem and the way to solve it by dynamic programming to get the greatest profit value and in a very short time. At first, I am talking about outline of the presentation, which is outline, introduction, background, knapsack problem methodology, use dynamic programming to solve knapsack problem, result and analysis, conclusion. Introduction. There are n things in the knapsack problem, and each one has a weight and profit connected with it. In order to maximize profit, the knapsack-friendly subset of the n items must be selected. The knapsack problem family is diverse and includes a wide range of knapsack permutations. There is just one way to play the 0 to 1 knapsack variation. The multiple choice knapsack difficulties arise when things must be picked from separate sets. When there are many knapsacks that can all be filled at once, there is another kind of knapsack. The knapsack problem has been solved using a variety of techniques and the issues complexity characteristics have been explored. Knapsack issues come in many varieties. We are trying to apply the dynamic programming algorithm to solve them. Now, background. Problems with the knapsack emerge in real-world decision-making situations where resources are limited and cost must be considered. In this company total optimization problem, we are trying discover the best possible solution for a limited selection of items. In CARBS 21 MP complete problems, the knapsack issue is one. In order to demonstrate that knapsack is MP complete, it was reduced to knapsack pieces cover. Many dynamic optimization methods based on Grady algorithm have been developed in recent years to deal with the dogs. In the simplest form of the issue it's easy to think of a solution that involves attempting every possible combination. It is feasible to try all to an potential subset of the total number of items in this exhaustive enumeration. The 0 to 1 knapsack issue was initially solved using dynamic programming technique by Pillman in 1954. Now, knapsack problem. Given a knapsack problem with an item I proved pi and wi and capacity of C can consider an example. All of these values are typically picked from the positive integers. As a result, it is necessary to pick a subset of n that maximize the overall profit of the selected item while minimizing the total weight. A linear integer programming paradigm can be used to solve this problem. It is necessary to choose a particle number of items from infinity number of objects with cast and weight qualities in order to acquire the greatest total cost while respecting the limit on the total weight. The set of Boolean vector x equal by x1, x2, x3, 2xn that meet the following condition is the set of possible solution to this issue. Methodology use the dynamic programming to solve knapsack problem. So, passing algorithm. In the dynamic programming, we will work considering the same cases as minutiaed in the discover approach. In a dynamic programming table, let's consider all the possible weight from 1 to W as the columns and the weights that can be kept as the rows. The state dynamic programming ij will denote maximum value of j weight, considering all values from 1 to I. So, if we consider Wi weight I row, we can fill it in all columns which have weight values Wi. Now, two possibilities can take place. Fill Wi in the given column. Do not fill Wi the given column. Now we have to take maximum of these two possibilities. Formally, if we do not fill I white in J column, then dynamic programming ij state will be same as dynamic programming I to 1j, but if we fill the white dynamic programming ij will be equal to the value of wi. Epsilon value of the column wing jwi in the pre-voice row. So, algorithm. Based on the following recursive algorithm, you create a table of alternatives to contain the dynamic programming algorithm. To ensure that the outcomes are acquired, firstly, the foundations of dynamic programming are in place. All zeros are included in the first line. use recursive formulae to compute each line or one at a time, starting with line 0 and working your way up to line 2 and so on. So, result and analysis. The algorithm is coded using Python script. After creating white matrix data set, the dynamic programming knapsack class processes the data set action and index passing on dynamic algorithm to update the Qtable and return results whereas in example w white equal 1 2 5 6 7 limit w equal 11 value equal 1 6 18 22 28. Result will be item 32 value 14 time 0.1428301 double 3 4 3 8 1 1 0 3 5. Seems the needed time of running the algorithm is very small, that make the algorithm useful for knapsack problem. The convergence of Q values of the saving table illustration with respect to action number in graph. Conclusion. This is one of the most often encountered optimization problem, and it is now as the knapsack problem. In the actual world, this problem may be used a variety of situations, including business undertaking, freight operations, encryption, and industrial decision-making methods. The dynamic programming with dominance approach proposed in the work may be used to solve the knapsack sharing problem, without encountering any difficulties. Knapsack problems are a type of issue that may be used to break down a large difficulty into a number of similar problems. When you use our strategy, you can resolve knapsack problem in a fair amount of time. In the end, I hope I was able to deliver idea of the problem and how to solve it. Thank you so much.